Hello everyone, welcome to my channel Cat by Nagendra. So in this tutorial, we are going to see basic introduction about these constraints in SolidWorks. So usually constraint is nothing but arresting the degrees of freedom. As you watch previous video which we have explained about this constraint, you will get detailed information about this constraint. Then in constraint already we know that we will be having here two types. One is dimensional constraints, nothing but applying dimensions. Then one more we are having geometrical constraints, nothing but applying relations. As you can see, different type of relations are there. So one by one we will see now. Now let's enter into SolidWorks. Let's say for example, we are having one point here. Now if we try to move this point is able to move with reference to horizontal and vertical directions. It means degrees of freedom for this particular point is not arrested. Now let me try here with dimensional constraints. Dimensional constraints is nothing but applying dimensions. Just I'll give dimension from this origin point to this point. Horizontal dimension I'll give like this. Let's say okay. Now if we try to move this point is not able to move with reference to horizontal direction, but it is able to move with reference to vertical direction. Now again I will go for dimension. Let me give dimension from origin to this one. Vertical dimension if I give here, as you can see, if we try to move that point, it won't move as degrees of freedom for this particular point as fixed. And here you can see it is showing fully defined. Before if it is able to move in any direction, here it is highlighting as under define. Under define is nothing but here it is under constraint. This profile is able to move freely. So once if we arrest degrees of freedom for this particular point, as you can see, here it will show as fully defined. Here you need to observe. Then next to that, let me delete this. Just I'll delete this. Now dimensions, with the help of dimensions you are able to arrest the degrees of freedom. Now we'll see how to apply these different type of relations. So first I'll go here with horizontal and vertical. So where we can use this horizontal and vertical and how to use means, let's say for example we have created one line, just inclined line I am drawing here. Now this line I need to convert into horizontal or vertical. So in that condition we can use horizontal or vertical option. Just I'll click on line, we are able to convert that line into horizontal like this. As you can see in green color, relation will be shown as horizontal symbol. Let me delete that relation. Same line, if you want to convert into vertical, we can convert into vertical here like this. So like this we can use horizontal and vertical line option for particular line. Then one more is, let's say for example we are having one point here, then one more point here. Now I need to add relation between origin point to this point. These 2 points should be exactly on this horizontal axis. So in that case directly we can go here with add relation. Relation between origin point to this point, we need here horizontal relation. Once if I click on horizontal, that point to this point it will be exactly on this horizontal axis. Let's say okay. Same like that again I'll use add relation. Origin point to this point, I'll make it here vertical relation. Once if I click on vertical, as you can see, properly vertical relation will be applied here like this. Let me say okay here. Now next we'll go here with coincidence. So coincidence will be used when we are having, let's say for example, this point is there. This point I need exactly onto this origin point. So in that case we can go here with add relation. Relation between point to point, we can make it here coincident option. So once if I click on coincidence, that point will join to that selected point and let's say okay. Or else again I will use add relation. Let's say for example this line, it should attach with this point. Between these two, if you make coincident, as you can see, that point or this line, it will be exactly coinciding one to one. It will touch one to each other. That is coincident option. Then next to that we are having here concentricity. So usually concentricity is nothing but Let's say for example, we are having here two circular profiles. So for this circle, we are having center point here, and for this circle, we are having center point here. Now I need relation between these two circles. Both circles should start with same center point. So in that condition, we can go for add relation. Relation between this circle to this circle, we need here concentric relation. Once if I click on concentric, as you can see, both circle will start with the same center point like this. Then next to that, we are having here co-radial. Co-radial means this one also same used for curvature profiles. Now let's say for example, again two circles are there here. Dimension for this we are having some diameter of 50. Then same diameter of 50 I need for this circle also, and this circle should be exactly overlap on this circle. So in that condition we can use here relation called co-radial relation. If I make it co-radial, one circle which will overlap on one more with a equal distance with the same center point here. That is co-radial option. Then next to that equal is there. So equal is used between two circular profiles. Let's say for example two circles are there. We need to make both circles with equal dimension. So instead of going here with add relation option, you can hold control. You can select multiple profiles. Directly you can apply relations here also. We need to make it here equal. As you can see, both circle dimensions will be equal now. Or else, let's say for example two different lines are there. One line is here. Then one more line I want. Let me draw one more line here. Small one I'll draw. I need to apply relation between this line to this line. If you make it here equal, both it will come with the same equal distance. That is the relation of equal. Next we are having here midpoint. So what is meant by midpoint means, let me delete all these things. Now let's say one line is there here. As you can see, with reference to this point, this side we are having less distance, this side we are having more distance. So we need to make this line exactly with equal distance on both directions with reference to this point. In that condition, just I'll click on this point and I'll click on this line. We are able to get here midpoint. Once if I click on midpoint, as you can see, this line will distribute equally with equal length with reference to this selected point like this. That is midpoint option. Then tangent relation is there. Tangent relation will be used when we are having one curve profile and one more we are having any line, or one more curve profile like this. Now add relation. Relation between curve to line. If you make it here tangency, that line will touch to this circle like this at the edge. Same again add relation between curve to curve also we are able to add tangency relation between these two circles like this. That is tangency relation. Then next to that we are having collinear. Collinear will be used when we are having two line profiles. Let's say for example, one line is here horizontal line. Then one more line we are having somewhere here like this. Now relation between these two lines, it should be overlap one on each other. It means this is a horizontal line. This line also we need exactly straight to that line. So in that condition, we can add relation between line to line. We can make it here collinear. So if I click on collinear, this line will exactly come straight to that line like this. This is collinear relation. As you can see, this line and this line will be on same straight line. Then next we are having here parallel. So just we can convert two lines into parallel. Let's say for example one inclined line we are having. We need to add relation between this line to this line. We need parallelism. If I click on parallel, it will be parallel to each other like this. Then perpendicular relation is there. Now let me draw one more line somewhere here, inclined line. So we need relation between line to line. We needed here perpendicular relation. Exactly with reference to that 90 degrees profile will be created. like this. This is perpendicular relation. Then last we are having here symmetric relation, very important relation. So what is meant by the symmetric relation means, let's say for example we are having one vertical construction center line here, like this it is there. With reference to this, let's say for example one circle we are having here with dimension of diameter some 30, dimension from this to this horizontally we are having 45, and this to this vertically let's say we are having some 30. Now this circular profile is fully defined here. Now let's say one more circle we are having here. We need to apply relation between these two circles, that whatever the dimension we are having for this profile, same dimension we needed for this, and whatever this horizontal vertical dimensions are also there with reference to the center line, same dimensions we need for this also. In that condition we can go for add relation, select first element, second reference element, third one we can make it here symmetric relation. Once if I click on symmetric, as you can see, properly whatever the parameters we are having for this circle, same will be applied this side. So like this we can use symmetric relation. Or else, let's say for example one line we are having here, like this. So with reference to this center line, whatever the gap we are having this side, same gap we need this side also. In that condition also we can use symmetric relation by selecting all three elements. If I click on symmetric, as you can see, equally with reference to this dimension will be distributed like this. So in this way you can use these relations. Then same in this case, one more option also you can use. Now let's say for example one line is there. As you can see, with reference to this line, here less dimension we are having, here more length we are having. In that condition, add relation between line 2. Once if I go on this line, we are able to select midpoint. So we need this point exactly at center, right? So just we can select that midpoint and we can make it here coincident option. That point it will get exactly attached to this construction line like this. In this way, we can apply this all relations and we can convert our sketch into fully defined sketch by using this add relation option. Then next option we are having here fully defined sketch. So fully defined sketch is nothing but automatically we are able to make fully defined sketch without using dimensional or geometrical constraints. Now let's say for example we are having some shape here. Let me create some rough sketch like this. So if you want to make this entire sketch fully defined, so we need to go here with the dimensional constraints or geometrical constraints, and proper relations we need to apply for this. Instead of that, directly we can go here with fully defined sketch. So either you want to make fully defined for only selected entitles or all entitles in the sketch. I'll go with all entitles, and if I say OK here, as you can see, with the help of dimensional constraints, entire sketch got fully defined here automatically. But you should not use in this way. Manually we need to give our own dimensions and proper relations to make it fully defined sketch. Then next option we are having here repair sketch. So repair sketch is nothing but, let's say for example one shape we are having straight to this. Here very little gap I will remove here. Just I'll mention some gap here. If I want to check, let me check gap between this to this. It got coincident. Let me delete that relation just by using this. I need to check dimension between this to this. A very small gap we are having here, 0.02. But if you make here fit, we are not able to identify where gap is there. So in that condition, by using this repair sketch, we are able to find out where error is there. Now let me click on this repair sketch. As you can see, we are able to adjust the gap. So we need to get gap between 0.04. As you can see, here it is getting highlighted, means gap is present here. So just we can close this and we can zoom in there and we can apply relation between these two let's make it here merge. It will attach to that. Now again if I check, nothing it will show. Why? Because entire profile is a closed profile properly. So that is the use of this repair sketch. Then quick snaps will be there, automatically it will be activated, so no need to select separately. And these options also let it be, we are not going to use this, let it keep like that only. Then shaded sketch contours option will be there. So whenever we are having closed profiles, if we turn on this option, closed profiles will be shown in this brown color. If you draw any open profile like this, it won't highlight with brown color. Only closed profiles we are able to identify by using this option. So this one also will be useful for us. So in this way, we can use all the options which are available under here sketch tab in SolidWorks. Now, if you have any doubts regarding this up to now, please let me know in comment box. Thanks for watching. Keep supporting